Okay, so here's the next item that we need to prove. As you can see, it involves a lot of square of the functions. In this case, we have it for cotangent and cosine. Okay, so to prove this, we have to select a side. And in this particular video, I'll be considering the left-hand side. So we start the proof by selecting the left-hand side of the identity. That's cotangent squared x minus cosine squared x. So we wish to change this into cosine squared x times cotangent squared x. Okay. Now in proving, there are a lot of different first steps that one can use. So if your first step is different to my first step, uh, it should not be a problem, because our goal is whatever steps that we will be using in proving, we should end with the cosine squared x times cotangent squared x, and that is the one on the right hand side. That's the only goal. Okay, the steps could vary, but the main goal is to transform the left hand side into cosine squared x times cotangent squared x. So here I'm thinking of changing cotangent squared x into cosine squared x over sine squared x. Okay, so note cotangent is equivalent to cosine over sine, so the square of cotangent is equivalent to cosine squared x over sine squared x. And then we copy cosine squared x. Now I can combine this into a single fraction. So combining this, we have cosine squared x minus sine squared x times cosine squared x. Okay, so if you're wondering why is there a sine squared x minus cosine squared x, we combine these two by writing this into cosine squared x over sine squared x minus cosine squared x times sine squared x over sine squared x. So since these two are the same, we could simply use this as a numerator, and at the same time we could interchange the position of cosine and sine. Okay, so that's how we got these two. Okay, now note we are trying to combine them into a single expression without the minus sign. So we can now have, you can actually factor out cosine squared x, and this will give you 1 minus sine squared x over sine squared x. Okay, so we use the right hand side as our guide. Take note, we were able to create a cosine squared x from here, and then we are left to find a way to change this into a cotangent squared x. Okay, now if you remember, sine squared x plus cosine squared x is equal to 1. That means cosine squared x is equal to 1 minus sine squared x. So this is now equal to cosine squared x times cosine squared x over sine squared x. And then you could make this cosine squared x times cosine squared x times sine squared x. And if you're familiar with the identities, you should already recognize that this is basically cotangent squared x. Hence, we were able to reach the right hand side of the identity. So we have proven that these two are identities. Okay, so just a quick recap on how we prove this identity, the moment you see a square, although not in all cases, the strategy is always by using um, by using the Pythagorean identities. At the same time, if you see the cotangent or tangent, you can replace them through or replace them with the expressions involving sine and cosine. And in this case, we replace cotangent squared x into cosine squared x over sine squared x. And we work on that. We tried to combine the two expressions into a single expression because the right hand side does not involve any minus or plus sign. And we also use some factoring because cosine squared x is common, and we were able to create this. Okay, and from here we already have the cosine squared x, so all we had to do was to convert this into cotangent squared x. Then we simplify through this identity, and then eventually we were able to reach the right hand side of the identity. Okay, so I hope you understand how this identity was proven. If you find something that is confusing, you may go back to that part of the video, and hopefully by watching it again, it will be clear the second time around. Okay, that's it.